Hello, my name is Bob Rinkevich, Field Applications Engineer with Linear Technology, here today to talk about LTpowerCAD, and in particular the Power Stage Design Screen, which is the schematic entry screen for a design in LTpowerCAD. Once you've selected a part in LTpowerCAD, you get a schematic template that has the basic power components that are necessary for the design of that circuit. It's a summary schematic. It's not a complete schematic, so it won't have all the components necessary for complete design. But it will have the basic power components that you have to select, depending on the kind of part. That may well be MOSFETs, as well as input and output capacitors and diodes, as well as the small signal components that are used for adjusting the output voltage, the frequency compensation of the feedback loop, setting the operating frequency, and the current limit setting. Again, it's a summary schematic, so it won't have all the components of a complete functional circuit. So you need to look at the data sheet, which will be explicit about the components that you will need for a complete circuit. The cells are color-coded to make it easy to be consistent about entering data into the tool. You'll see on the left is a color code for the basic cells of the tool. The cells in yellow are reported by the tool, either as properties of the part that you've selected or as suggested values to use in the circuit. The user values are put into the blue-green boxes. Blue-green will show on a box that is empty or has been filled with an appropriate value. Further, there's a cue if the value is out of the ordinary range or farther. There's an orange for a warning that the value is outside of the recommended range. That it'll probably still work, but you should check it. And there's a further alert level when the value is critical and can be significantly affecting the circuit's operation, and the circuit might not work properly. There are other controls on the interface when appropriate. For example, for setting the current limit on this part, there are possible settings of 30 millivolts, 50 millivolts, or 75 millivolts for the full-scale input to the current comparator. So those are choices all available in a drop-down menu. Again, on this part, this is a current mode part that looks at the inductor's current with the current comparator, and the circuit can be configured to use a dedicated resistor for that current information, or the configuration can be changed to use the inductor's DC resistance and an integrating network to sense the current. So changing that setting will cause a change in the appearance of the schematic. Selecting components in LTpowerCAD is made easier by the extensive libraries of components included. So to open up a component library for a particular component, hover the mouse cursor on the component that you would like to select and left click on it to open the component library for that component. So here I have the cursor on the inductor and open the inductor library. And further, you can sort on any of the parameters. So for example, I want to look at inductors that are near 0.4 microhenries and 20 amps saturation current, and I can put those values in, and the part of the inductor table bracketing those values is brought up. The entire inductor library consists of thousands of parts, so using the search boxes to narrow down your selection helps quite a bit. There's a toolbar across the top of the screen, and I'll just scroll through those functions briefly. There are tools for zooming in and out of the schematic. So for example, you can scroll to the complete extent of the schematic or zoom into a particular part. Exporting the schematic can be done by printing an image of the schematic or exporting a bitmap. There's a library of LTpowerCAD examples that have already been worked out for the part that you're working with. a little summary of the design steps and a recommended sequence for going through. That's useful if you're working with a type of regulator you're not familiar with. A set of design curves can show the operating conditions for the major components. So in this example, the capacitor current stresses over the operating input voltage range, etc. There's an annotation tool for adding text boxes. You can view a layout example, which is an annotated version of a vetted demo board. There's an export utility to take the values you've entered in the schematic and export them to an LTSpice template, so you can use further analysis with the nodal simulator LTSpice. There's a toolbox of ancillary tools, which I won't go into right now, but also a link to the complete data sheet and all the documented demo boards for that part. Finally, on the toolbar is a component settings box. This is an automatic correction for the capacitance value as it changes with DC bias on multi-layer ceramic capacitors. If you use the nameplate value for ceramic capacitors, you may be surprised by the actual operation of your circuit, as the farad value changes considerably with DC bias. So the capacitors in the library have been curve fit to correct for this. You can invoke that, or if you have your own measurements or vendor data that you would rather use, you may use that. LTpowerCAD installation file is a free download at the address shown on the screen. Thank you for your interest in LTpowerCAD.